Okay, so I've got a couple pages to show you today, and I'm going to go through them pretty quick. This is the practice day 2 to get you ready for tomorrow's test. So this is complete the table. There's not much information given here except for 4 and 6. If 4 is 6, then 2 is 3. I just cut it in half. If I cut it in half again, it's $1.50 per minute, and then times 10 would be $15 for 10 minutes. So all of these should be money. Should look something like that. How much? It's $1.50 per minute. We see that right there. Write an equation. Money donated D equals $1.50 times T. If they dance for 60 minutes, I just do 150 times 60. That's going to equal $90. And then using the table of values, graph the relationship. And I don't have the graph here, but it looks something like this. Along the bottom, I've got time and minutes, time, and then along the side, I've got donations in dollars. D. See, for most of you, like this would be, along the bottom, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I need like 2, 4, 6, or maybe even if I make every other line 3. Oops, I'm going to run out of space on this one, but you guys should be able to do it on yours. I've got 1 is $1.50, 2 is $3, 4 is $6, and 10, if I follow that, it's going to be like out there somewhere. And so then this is what would the point 1827, it's off my chart, but 1827 means for 18 minutes equals a donation of $27. Okay. We've got a bunch of task cards. 6 squared is 36. 3 squared is 9 times 4 is 36. So this is the one that doesn't match. I've got 8 times 4 is 32. 5 squared is 25. Plus 9 is 34. 2 squared is 4 times 16 is 64. 8 squared is 64. So that one. I've got 3 times 3 times 3 is 27, plus 3 is 30. 6 squared is 36, plus 2 is 38. And 4 squared is 16, plus 16 is 32, minus 2 is 30. So that one there is the odd one. Create your own challenge. I don't know, like I always liked 3 squared times 2 squared. That's 9 times 8 is 72. That's the same as 2 times 6 squared. 2 times 36 is 72. And then I can pick anything. Like, a lot of people think that 7 squared is 72, but it's not. It's 49. In each row, choose an equation to solve. I'm going to solve them all. You can pick whichever ones you want, but like this first one, I subtract 24 from both sides. I get negative x equals negative 11, or x equals 11. If I do this one, I get that x equals 16, 2/3 of so the 3 and the 24, that becomes 8. 2 times 8 is 16. And then lastly, p equals 4. P equals 750. X equals 36. Over here, I get that it's 23 and 1/3 plus 2/3 is 24. I get P equals 4. And something minus 13 equals, so I add 13 to both sides. X equals 37. And here X equals 9. And so you're supposed to pick one in each row and solve it. Down here, Sol has $10 to spend. That's like $250. P equals $10. That was C. So P equals 4. And that's how many, 4 loads of laundry. Zara's got 24 minus 13 equals X. That one is 24. She drank X. How else could I write that? That might be the 24 minus, sorry, the other way around. 24 minus X equals 13. I get X equals 11. 11 ounces left. That's what that means. This one is that 2/3 times 24 equals X. I get that X equals 16, and that's 16 feet squared of moon flowers in this situation. What advice would you get? Inverse operations, I think, is the clue. Inverse ops. Use inverse ops every single time. Here's a rectangle. I got 7 times. I've got 2x plus 1, so that's 7 times 2x plus 1 is the same as 14x plus 7. Which one is that? That's B. What's the area? If x equals 6, I'm just going to do 2 times 6 plus 1. That's 13. Times 7 is 91. If it's 1/4, 2 times 1/4 is a half plus 1. 7 times 1 1/2 is 10.5. 10 1/2. Select any 3 equations, draw an area model. So the first one is going to be 1/3, and then I'm going to have something like 6x plus 12. That's the same as 2x plus 4. The next one, 14 and 2a, I get that that's a 2, and I can do 7a and b. That's where I get that 14a plus 2b. 4 plus 5x, that's normally vertical like this. I get an x, 4 and 5, 4x plus 5x, also known as 9x. And lastly, 5 goes into both of those. So I'm going to get a plus 2b is 5a 10b. Writing the equivalent expression each time the inside versus the outside are equivalent. And then I get to this last one, and it says, here's an equation. Fill in the blanks to create an equation that's true. Like, I know that 3 squared plus 4 squared does equal 5 squared. Fill in the blanks that's not true. Well, any other one, like 1 squared plus 2 squared does not equal 3 squared. The only reason I knew this one was because of Pythagoras. If it's a 3, 4, 5 triangle, a squared plus b squared equals c squared. Is it possible to create more than one true equation? I'm going to say yes and no at the same time. Like, I know that 5 squared plus 12 squared equals 17 squared, but 12 and 17 aren't one-digit numbers. So in this case where there's just one box, I'm going to say no. There's no other single-digit solutions. I mean, there's like an 8 squared plus something and a 7 squared plus something, but they're going to be all double digits. Okay, that's everything I need to know to get ready for this test tomorrow. So good luck, study your notes, and I'll see you in class tomorrow.